Hello all. In this video, we'll be extending what we have done in the previous video itself. We will be looking at the aromatic compounds viewer. Okay. So let's start with it. What we are going to do. So we are creating a web application using Streamlit framework designed to display the structures of aromatic compounds based on their smiles. So smiles are the entry point for molecular structure where we give some representation, and after that we work on it. So the web application provides an interactive and user-friendly interface for visualizing these chemical structures. So what we are trying to achieve, we are using Python, Streamlit and RDKit for this. First we are importing the library. Streamlit is as st, that is we are extending it as a particular name itself for st. We are bringing in RDKit, a collection of informatics and machine learning tools. It's used here to handle chemical information and generate molecular images from smile strings. We are processing the user input. The inputted smile strings are split into individual strings separated by commas, or we can put in single if you want to. These individual strings are trimmed of any leading or trailing spaces. Then we are generating and display the molecular structures. Generating and displaying molecular structures for each smile strings in the list. The code generates a subheader with the smile string. It converts the smile string into a molecular structure using chem.mol from mol from smiles. If the molecule is valid, it uses draw.mol to image from RDKit to create an image of the molecule. So our perfect combination is to get the image of that particular molecule itself. The image of the molecule is then displayed in the app using st.image. If the smile string is invalid, an error message is displayed. So the entire working is being shown over here, where we are inputting the the smiles and processing each smiles as we have mentioned, splitting the user input into individual smile strings and convert smiles to molecule using chem.mol from smiles option, and check if the molecule is valid, and after that we are displaying the molecule using draw.mol.image that we have already mentioned. And if there are errors, we get the errors we'll get an invalid message from this. So let's start this application. We'll just wait for a while. Now it's being initiated. You see 4 examples were given and they have been visualized. So let's take an example or some typical strings. So benzoapril, that is this particular compound itself, is polycyclic aromatic compound, and we'll just use it accordingly. So the smiles for this benzoapyrene is this. I will just use it and see that if it works or not. We'll pass it along here, and I will just hit Control and enter. Let's see it once. Control enter and you get all the details of it. Now I'll change with another molecules also to smiles format to check if it works or not. This is coronine. So this is also a complex compound. So this is also created again, and we'll pass it along another compound, another smile. then smiles for anthanthrene, if I spelled it right, made up of 5 linearly fused benzene rings. Okay, and the final one being this one. This is also a complex structure. We'll have to see if it gives the results or not. So I'll just split control and enter and see like if all of them are being processed. As you can see, all of the smiles are being processed in a proper manner. So we have successfully created an aromatic compound viewer, and to deal with complex situation I have provided some polycyclic aromatic compounds to see if they are we are getting good output or not. So this is the part of the code, not a like a very complicated one, but this is a progress we are doing, and also we'll share more updated information because I am working on a lot of applications related to bioinformatics, and you see like there's an aromatic classifier. We'll show it step by step in other videos. Thank you. And I will also share the GitHub link so that you can go through the details of it. Thank you.